Welcome to Simplifying Radicals Part 2. Hopefully you're able to look at Part 1. What I want to talk to you about is some of the more complex simplifying radicals that you'll see coming up this year in AAT. The first thing that people wonder about is what happens if there's more than one radical? Okay, so say that you see something like the square root of 3 times the square root of 12. Okay, they're like, how do you do that? Well, the thing is that because they're related by multiplication, just like when you had, say, the square root of 50, and you could break that up into the square root of 25 times 2. Remember, we looked for the biggest perfect square that goes into this. We wouldn't want to do 5 times 10 because neither 5 nor 10 is on our list. We're looking for the biggest perfect square, if there is one that goes into it. And then we broke it up into 5 square root of 2 as our answer. Remembering that the product of 5 times the square root of 2 should equal the decimal equivalent to the square root of 50. And you can check that on your calculator as well. So just like you can break down this into the product of 20 squared 25 times the square root of 2, so if you see 3 times the square root of 12, you can break that down into the square root of 36. And then you look at this and say, do I know that? Can I break it up? Or is that just how we should leave our answer? And the square root of 36 is 6, so that would be our final answer. The thing is also, if you've got a couple things here, what if you've got 2 square root of 8 times negative 3 square root of 6? In this problem, you have 4 factors multiplied together. The 2, the square root of 8, the negative 3, and the 6. And so one option, is to multiply the 2 number factors together. You get negative 6. And then you can multiply the radical factors together, and you get 6 times 8 is 48. And that's true. But then we say, all right, is there a perfect square that goes into this? 4 goes into it, but the biggest perfect square that goes into it is 16. 16 times 3. And so, again, these are 3 factors multiplied together. And we know the square root of 16 is 4. And so the answer is going to be the negative 24 square root of 3. And that's our answer here. They get more complicated sometimes on some of the problems that you'll see. Example would be the square root of 1/2, or 1/2 square root of 5 times 2/3 the square root of 7. Again, 4 items multiplied together. Multiply the number factors together. Half of 2/3, multiply the numerators, you get 2. Multiply the denominators, you get 6. 2 6 is 1/3. And that would be the square root of 35. And as you remember, you could put that as, over 1. You could make that the square root of 35 over 3. Both of those are true. Look to see, does the square root of 35 break down? And the answer is no. There's no perfect square other than one that goes into the square root of 35, so you're set on that. Sometimes, they give you a multiple, like the square root of 7 times the square root of 7. It's multiplied by itself. Again, the square root of 7 times the square root of 7. When you multiply those together, you get the square root of 49. What is the square root of 49? That's 7. Okay, so when you take the same square root by itself again, notice what occurs. They're just looking to see if you can figure out a pattern. Another thing is, if you see the square root of 11 squared, you can look at this and say, well, I can write this. This means just take this by itself again. Just like 5 squared means 5 times 5, so the square root of 11 squared means the square root of 11 times the square root of 11 again, which gives us this, which is 11 as well. And so we're just looking to see, write it out again, find your answer. The other thing is, we've talked about inverses. The inverse of adding is subtracting, the inverse of multiplication is division, the inverse of square rooting is squaring, and that's why when you see a square root squared, they actually are inverses, and your answer will be what you see. They get slightly more complicated. Example would be like the 3 square root of 5 squared. Well, that means take 3 square root of 5 times 3 square root of 5 again. Multiply the number factors, you get 9. Multiply the radical factors, you get the square root of 25. And remember, they're multiplied. 9 times the square root of 25 would be 9 times 5, which is 45. Another way to think about it is, because these are related by multiplication, you can just square each of these factors. You can square the 3 and you get 9. You can square the square root of 5. When you square the square root of 5, notice, remember, these are inverses, you get 5. Okay, and so you get the same answer of 45. It's kind of your choice how you think about it. If you just think about this as repeated multiplication, take this by itself again. Or if you say, well, let's square each of those each of those factors there to get our answer. All right, we need to talk about how to add and subtract, okay? And you guys may notice that on your homework you'll see say the square root of 7 plus the square root of 7. And again, that doesn't give us the square root of 49. That's crazy. What we're asking is, what is the square root of 7 plus the square root of 7 again? And notice, if it's adding, you can only add if they have the same radical. So that's like 1 square root of 7 plus another square root of 7. That would be 2 square root of 7 for your answer. If you had 5 square root of 3 plus 2 square root of 3, that would be 7 square root of 3. Kind of like 5x plus 2x is 7x. The radicals and the variables would have to be the same. If you had 8 square root of 5 minus 2 square root of 3, that would be as far as you could go, and because the radicals are not the same. There are times, however, where you've got, say, the square root of 40 plus the square root of 90. Okay, I can't add them as we see them. However, if you simplify them first, notice the perfect square that goes into this would be 4 times 10. Square root of 4, square root of 10 is 2 square root of 10 plus square root of 90 will break into 9 times 10. The biggest perfect square that goes into 90 is 9. And so that would be 3 square root of 10. So notice when we reduce these, they both have the same radical. So your answer to that would be 5 square root of 10. So, and just so that you guys can pick up on that. Again, if they don't have the same radical, simplify them, but that's as far as you can go. You can't add or subtract items that are not like terms. Now, we also are going to be talking about simplifying fractions, and I'll do that in the next video.